Hello friends, I am Priyanka Chakraborty. In my previous video, I was discussing about the definition of electronics, where we use electronics. I told you that we use electronics everywhere in our daily life. I was also discussing about the concept of electrons and free electrons, and according to valence electron, the concept of conductors, semiconductors and insulator. Here we see the atomic structure of silicon, which has 4 valence electrons. Actually, I will be discussing about BJT, FET, feedback amplifier, multivibrator, etc. later. For this, we have to know about semiconductor and diode property. So today, I am discuss about the energy band diagram. For that, we have to know the Bohr's atomic model. In the Bohr atomic model, the electrons are assumed to move about the nucleus in certain discrete circular orbits without radiating any energy. That means every shell of an atom contains a discrete amount of energy at different levels. Okay, so this is the energy level diagram in which first orbit represents the first energy level, second orbit represents the second energy level, and so on. These allowable energies are represented by the horizontal lines in a diagram. This is known as energy level diagram of the atom. An electron normally occupies the lowest energy state called the ground level in an atom. The other line in the higher energy levels are called the excited levels of an atom. By absorbing more and more energies, an electron can move into excited state which are further and further away from the nucleus. If the energy is sufficiently high, the electron can overcome the attraction of the nucleus and gets detached from the atom. The energy required for this to occur is known as ionization potential. So when an electron jumps from a higher energy level EH to a lower energy level EL, an electromagnetic radiation of frequency nu is emitted, where we can say the nu equal to EH minus EL by H, where H is the Planck's constant. So here we see the energy bands. Where is energy band? The range of energies possessed by an electron in a solid is called energy band. Now we can see a figure. Here, the first two figures represents the energy of different orbit of an atom, which is represented by the diagrams that is known as energy level diagram. Now, let me discuss about the figure shown to understand clearly the energy band theory. The second figure represents the energy level of a single isolated atom. Each orbit of an atom represents a single energy level. However, when an atom is in a solid, it can have a range of energies. Now, electrons in the first orbit have slightly different energies, as no two electrons in an orbit have the same energy. These slightly different energies level form a band. It is called the first energy band. Similarly, the second orbit of electrons form the second energy band, and so on. We know that the electrons which are present in the outer shell known as valence electron. So now we are discussing about some important energy band in solid. The valence electrons include a sequence of energy levels which form an energy band known as valence band. This band includes the maximum occupied energies. Some of the valence electrons are attached loosely toward the nucleus at the room temperature. These electrons will leave the band free. This known as free electrons. These free electrons will conduct the flow of current within a conductor, which is known as conduction electron. The band which includes these electrons known as conduction band, and this occupied energy will be less. So we can say that based on the energy band theory, there are three different energy bands. One is valence band, another is conduction band, and another is forbidden energy gap. The range of energies possessed by the valence electron is known as valence band. The range of energies possessed by the conduction band electron is known as conduction band. And the separation between the valence band and conduction band on the energy level diagram is known as forbidden energy gap. So, what is conductor? The conductor is a type of material where the forbidden energy gap will not exist. Like the valence band and conduction band is overlap to each other. It has higher conductivity and low resistivity. In case of insulator, the forbidden energy gap is extremely high. It has extremely low conductivity and high resistivity. We know diamond is an insulator whose forbidden energy gap is 6 electron volt. And in case of semiconductor, the forbidden energy gap is very small. The electrical properties of semiconductor lies between metal and insulator. So we know that the germanium and silicon is the semiconductor. So the germanium has the forbidden energy gap of 0.72 electron volt and the silicon have 1.1 electron volt. We know that 1 electron volt equal to 1.6 into 10 to the power minus 19 joule. So this figure shows the difference between the solid, metal, insulator and semiconductor. Okay, so there are some questions, important questions from this portion. So that's all for today. If you like my video, then please like and subscribe my channel, and you can also give me some suggestion to improve my videos. And if you want to get the idea about any other topics in electronics, please drop it into the comment box. So thank you and goodbye. Stay safe.